All right, so exam practice questions on rational and irrational numbers. Now, as we know, mathematics, we don't use a calculator, and so you need to make sure that you are very careful the way you are getting to solve these questions because no calculator is required, right? So the first question, express the following in the form a over b, where a and b are integers and b is not equal to 0. So the denominator can't be equal to 0. And these two questions we are seeing here are just coming from last year's final exam. The first one was from last year's final exam. The second one was from last year's supplementary exam. So when you want to show that a number is rational, or when you want to express a number in the form a over b, the first thing, let it be equal to some letter. All right, so I'm starting with a. So let x be equal to what you've been given, 3.142. Now, please take note of where the bar on top is starting and where it is ending. Otherwise, if you don't do that, you are going to get it wrong. Okay, so the bar is starting from 1 up to 2. So that is going to be the first equation. Let me call it equation 1. Now, after then, the next thing that you have to do, make sure that the decimal point is in front of the bar. Make sure that the decimal point is in front of the bar. Now, in this case, the decimal point is already in front of the bar. That means that that stage is going to be skipped. After making sure that the decimal point is in front of the bar, also make sure that the decimal point is behind the bar. And so that means that it should be behind 2, right? So I need to move. Let me ask this question. How many times should I move the decimal point so that it goes behind the bar or it goes behind 2? Anyone, please, who can answer me? You can just open the mic and speak. Very good. Okay, so for me to move the decimal point 3 times, I need to multiply equation 1 by what number? Very good. Very, very good. So multiply by 1000. So what you are multiplying is if I say equation, I mean x is equal to. So multiply x by 1000, that is going to be 1000x. And then multiply the 3.142 also by 1000. So it is going to be 3142. So the decimal point will come here. Now, just to maintain the digits that are after the decimal, I'm just going to write them also 142. Since we know that they are repeating, I'm also going to put a bar on top. This is going to be the second equation. Is someone behind because of this? Please, you always need to make sure that you put, after you've moved the decimal point, put those digits which are repeating also at the end. Are we okay? Right. After then, you now subtract these two equations where the decimal point is in front of the bar and where the decimal point is behind the bar. So what we are going to do is equation 2 minus equation 1. I'm going to write equation 2, that is 1000x being equal to 3142.142, and then x is equal to 3.142. So these are the two that we are getting to subtract. Just a moment, you get to see what I've written here. All right. So there we are. 1000x is equal to 3142.142 and x is equal to 3.142. Remember, we are subtracting. So begin by 1000x minus x. What value are you going to get? Anyone? 1000x minus x. Are we following what is happening? Okay, so that is going to be 999. Don't forget x. And that is going to be equal to, now the many instances as to why you even wrote the 0.142 on both equations, because the 0.142 on the first one, 0.142 on the second one, they are more going to cancel out. So what will just remain is 3142 minus 3. Very simple. You see, at the end you shouldn't get a value that has got a decimal. All right, never get a value with a decimal. I'm going to remove a 1 from 4, it remains a 3. I'll put here. So it is 12 minus 3, that should be a 9. And then we have got a 3, and then a 1, then a 3. So that is 3139. Mean that x is going to be equal to 3139 divided by 999. So this is the value. Now if this answer can be reduced in simple, so if you just reach here, you would have gotten almost everything. If it cannot be simplified further, then you have gotten everything. But if it can be, the way this question is 4 marks, if this question can be simplified further, or maybe there's a number that can go on the number on top and down without leaving a remainder, then you are going to get 3 marks. But the way it is, you can't simplify it any further, so you are going to get all the 4 marks on this part. So that is how you get to answer this. I hope it is okay. Please, for me, when you have got a question, I think I'll be more glad you ask and get it correct in the quizzes that you are yet to write and in the test one and the final exam than you being quiet if you have not understood. So that is the first one. So the next one, in the same vein, but the only difference is that the decimal point, so I'm going to say also let x be equal to 3.142. So from here, the only number that is repeating is a 2. Okay? The first thing, make sure that the decimal point is in front of the bar. So how many times can I move the decimal point so for it to be in front of the bar? Very good. So this is equation 1, meaning that I'm going to multiply it by what? To move it 2 times? Good. Multiply 1 by 100. So that will be 10 times, I mean x times 100, that is going to be 100x. And then 3.142 by 100, that is going to be 314. And then 0.2. Okay, this is going to be equation 2. And then the next thing, make sure that the decimal point goes behind the number repeating. Okay, so you can either multiply equation 1 or multiply equation 2. It's up to you, as long as the decimal point goes behind the number repeating. So I'm going to say multiply equation 2 by what number, so that the decimal point goes behind the number repeating? By 10. Very good. If we were multiplying equation 1, we would have multiplied by what number? By 1000, right? Since you wanted to move 3 times, look at equation 1. There are 3 decimal places. So multiply by 1000. So since we're multiplying equations 2, so 100 times 10, that would be 1000x. And then 314.2 times 10, that is going to be 3142. Put a decimal and just write the 2 again. Okay? Just to make sure that the decimal point is the same. The numbers after the decimal point in the equation where it is before the decimal point, before the repeating number and after the repeating number is the same. And so when you reach here, the 2 equations that you're supposed to subtract is the one where the decimal is in front of the repeat number and where the decimal is behind the repeat number. Priska, you have a question?
Now it's clear now.
All right. So, which two equations are we going to subtract?
Equation 2 and equation 3.
Very good. So, subtract 3 minus 2. You can even do 2 minus 3, but it will give you negative numbers. So, I know people will get confused a bit when you get to use negative numbers. So, you'd rather get the bigger one and then minus the smaller one. So, now 1000 minus 10, that is a 990x, and that will be equal to the 2 after the decimal in both equations is going to cancel out. Let me just give it a minute so that you get to see what's there. All right. So we are subtracting 1000x minus 10x. That gives us 990x. What if we subtract 3142 minus 314? What are we going to get? So you don't use a calculator, right? So just write this 3142 and then 314. This is what you're subtracting. You can remove a 1 from this 4, it remains a 3 you put here. So it is 12 minus 4, which is 8, 3 minus 1, which is 2. And then you can also remove the 1 here, it remains a 2. Put on the 1. 11 minus 3, that should be a 9, and then 2. So this is 2928. So though that is taking a bit of long to show there, it will just a moment it will show. Actually, it's supposed to be 8 again, right? Since we are subtracting 11 minus 3. Yes, there's a hand.
Equation 2, isn't it supposed to be 100x?
Equation 2. Oh, so what was I writing myself? I wrote, you are right. This is supposed to be 100x. Very right. I was thinking of another equation. I don't know where I got it. So 1000x minus 100. What are we getting? 1000 minus 100.
900.
900x. And then if we subtract 3142 minus 314, that is a 2828.
28, 28, yes.
Okay. And then meaning that x is going to be equal to what? 28, 28 divided by 900. For such a question like this one, also check if you can divide it, if you can simplify. Otherwise, if you don't simplify the way this question is, the 3 marks, you are going to get 2 marks. Okay? So this one, a 2 can go into, first you can start with a 2 which can go into both. You simplify, you can see if the value you get can also be simplified further. So the final answer is supposed to be 707 divided by 225. Are we good?
Yes.
Mr. Renford, you can just switch off the camera. Thank you. Okay. Priska, you have a question?
So, again, those questions are by probably they haven't put any bar there. So, what can you do to such a
Actually, that one is for high school if there is no bar.
question? There's no any repeat thing here.
Rainford, switch off the camera. It's a bit of tripping the network. So if you've been given 1.25, you want to express in the form a over b. Also equate it to 0, right? I mean equate it to x. And then for this one, it will be direct. Move the decimal point to the end. So I'm going to multiply this equation by 100. So x times 100, that will be 100x. And then 1.25 times 100, that will be 125. Then divide both sides by 100. So x is going to be 125 over 100. You've expressed it. Just look for a number that can go into 125 and 100 without leaving a remainder. Priska, that's okay?
Yes, sir, it's clear.
Prove that the following numbers are irrational given that square root of 2 is irrational. You guys, you need to be very careful when it comes to proving this because mostly people get to lose some marks because of wrong English they are using. You need to write some English here, right? So the first one, you've been given that 1 divided by 2 square root of 2 minus 1 is, you want to prove that it is irrational. The first thing, dear friends, is you use the assumption or the contradiction method. So assume, all right? Assume 1 over 2 square root of 2 minus 1 is rational. If you don't write this, it means everything you are going to be doing is meaningless, because how do you go at the end and say, since it is contradicting, if you didn't assume? That would be wrong. So first assume what you've been given is a rational. And you know that when this number is rational, it means it can be written in form of what? Who can answer me? It can be written in the form of what?
A over B.
Yes. So if we have assumed that it is rational, mean that 1 over 2 square root of 2 minus 1 is going to be written in the form A over B. And you know that A and B are co-primes. In other words, there is no number that can go into A and B without leaving a remainder except from 1. Okay? Or A and B are integers in their simplest form. That's what we mean by co-primes. I'm going to take 1 the other side. So I'm going to have 1 divided by 2 square root of 2 being equal to A over B plus 1. From here, we're going to have 1 divided by 2 square root of 2 being equal to, simplify, A over B plus 1. That is going to give you A plus B over B. Like this is a simple fraction. I'm doing this because we learned these fractions in high school. It is not a duty of anyone to teach these fractions, how to measure a single fraction in higher education, right? So from here, I'm also assuming that we know I'm going to take 2 root 2 on top. I'm going to take 1 down. If I do that, that means also these are going to swap directions. I don't want to do the cross multiplication. That should be for high school, right? So this is going to be 2 square root of 2 being equal to A over A plus B. I'm going to divide both sides by 2. Okay, so I'm going to have square root of 2 being equal to A divided by, since I've divided both sides by 2, I'm going to have 2 open brackets A plus B. Yes, Priska?
So on that equation, is it not supposed to be B over 2 plus B?
B over 2 plus B.
Yes.
Which equation?
Like the thing is A plus B over B. So when swapping them, we're supposed to have B over A plus B. You've written A in place of B.
Oh, the B was the one which was down. That is correct. That is correct. Okay, so are we all okay up to this stage? Are we all okay up to this stage? Okay, let me ask. Do we have a question before we make the final conclusion? Like if you reach here, this question is 4 marks. They'll give you 3 marks. Okay? Or even 2 marks because you have to conclude. Any question that they say show or prove At the end, you need to say hence proven. If you don't write hence proven, you would have already lost 1 mark. That is how it is here. So make sure that you do that. Yes, Priska.
Yes, sir. I'm not clear on how that two, how the root has remained alone.
I've divided both sides by 2. Both sides by 2.
Okay.
Yes. Now, when you reach at this level, this B, remember we said where A and B, I should have written A and B are integers. Okay, so since B is an integer, on top, down also we have got two integers A plus B. When you add two integers, the answer will always be an integer, dear friends. Negative 1 plus 5, the answer will be an integer. Negative 7 plus 7, 0 times plus 4. As long as you add or subtract integers, the answer is always an integer. And when you get an integer A plus B, you multiply by the integer 2. The answer will be an integer. Every time you multiply an integer by an integer, the answer is always an integer. And on top, you have got an integer. Down, you also have an integer, meaning that a fraction is rational. All right? So you now make the conclusion. Since the A on top and the denominator, which is the 2 times A plus B, are integers, that means that a fraction is a rational. Therefore, a rational number cannot be equal to an irrational number. Remember, we are saying square root of 2 is equal to B over 2 A plus B. And we know we've been given that root 2 is irrational. And we have said that this part is rational. So you say, since B and 2 open brackets A plus B are integers, meaning that is the right hand side is rational, because an integer over an integer is rational. But left hand side is irrational, because we know that square root of 2 is irrational. And you know, an irrational number cannot be equal to a rational number, hence contradicting our assumption. Therefore, square root 1 over 2 square root of 2 minus 1 is irrational. We've proven. Yes, Priska?
So, sir, when it comes to the conclusion, we always have to refer to us is the rules that are obeyed during when you're dealing with rational numbers.
Yes, yes. That is very, very important. Otherwise, many people don't get the full marks on this question because they don't know how to write a conclusion. All right. So make sure that you write a conclusion well. Okay, we can look at the next part. Next question. Priska, your hand is still up. You have another question.
No, I forgot my name.
Okay. If you have got a question, be free to ask. Be very free to ask. Like, whether you like it or not, these questions are coming in your test one, quiz one, and then the final exam, whether you like it or not. Like, it's a must. There are some topics where you, even if you are not a prophet, you should know that this is coming. Okay, prove that square root of 2 to the power 5 minus 1 is irrational, given that 2 square root of 2 is irrational. Also assume, all right? Assume that should be the first thing. So assume that square root of 2 to the power 5 minus 1 is rational. Let me ask again. If it is rational, then what is the condition that applies?
It should be expressed in the form of A over B.
Okay, very good. So meaning that square root of 2 to the power 5 minus 1 is going to be equal to A over B. Also write where A and B, you can write co-primes or you can write integers. It's okay. And also b can't be equal to 0. I'm going to take 1 the other side, so we're going to have square root of 2 to the power 5 being equal to a over b plus 1. That will give us square root of 2 to the power 5 being equal to a plus b over b. Let me now remove something on top here. Now from here I need to simplify. Square root of 2 to the power 5 means multiply square root of 2 5 times, right? So I have square root of 2, square root of 2, square root of 2, square root of 2, and square root of 2. So if you get these two, square root of 2 times square root of 2, what's the answer? It's 2. And then the next square root of 2 times square root of 2 is also 2. And then we have got this square root of 2 which we can't multiply. So what we have is 2 times square root of 2. That is 4 square root of 2. And that is going to be equal to a plus b over b. To remain with square root of 2, square root of 2 is going to be equal to a plus b over 4b. Right? Very good. And then from here, we can make a conclusion. On the right hand side, we have got a plus b over 4b. A plus b is an integer. 4b is an integer, meaning that the right hand side is what? Rational. And then the left hand side is what? Irrational. And an irrational number and a rational number, they don't have an intersection. In other words, they are disjoint sets. They don't have an intersection. All right? So since a rational number cannot be equal to an irrational number, that violates our assumption. Therefore, square root of 2 to the power 5 minus 1 is irrational. We have shown. So I think for this one we have already done. We can be able to answer. You can choose one that I should do, A or B, since we have already done something. Priska.
Yeah, I have a question in that one. Suppose if they give you maybe the square root of 2 plus square root of what is or 5, how can you prove it that it's irrational?
Okay, I think I have got a question in this practice. We're going to look at it.
Yes.
Okay, you can choose one on these two questions here which we should answer. Or maybe I just leave it out.
Leave them.
Okay, very good. Okay, let's answer this one. Find the integer values of A and B, and you should answer those two questions we've left on top. If you can send me the answers in my inbox. We see if you get them correct. Find the integer values of A and B given that A over B is equal to 1 over 2 square root of 3 plus 1 over 2 minus square root of 3. We want to find the value of A and B. And it says integer values. I hope we know what integers are. Is 1 over 2 an integer? Hello? Is 1 over 2 an integer?
No, it's not.
What of 1.5? What what of 1.5? Is it an integer?
No. The reason this is that integers cannot be expressed, do not have decimals, or neither are they expressed in form of fractions.
What of what of 4 over 2? Is it an integer?
Yes, because you can reduce it.
Very good. So fractions which you can't reduce and decimals are not integers. All right. So for this question, one option you have is to rationalize the denominator of the first part rationalize the denominator of the second part, and then the final answer add it. But another option that I have is just to make this as a single fraction. I'll get what is on top of the first fraction, that is a 1, multiply with what is down the second fraction, that is 2 minus root 3. So that will be 2 minus root 3. I'll get what is on top of the second fraction, multiply with what is down the first. That is going to be plus 2 plus root 3. And then multiply the two denominators. Now, what do you know about these two denominators? What are they called?
They are different conjugates of each other.
Very good. They are a difference of two squares, or they are conjugates, right? If you multiply them, that is going to be a difference of two squares. So that means it is in the form a squared minus b squared. Do you know that a squared minus b squared is a minus b, a plus b? So every time you have got a minus b, a plus b, get the first one, you square it, and then get the second one, you square it. Always put a minus on the middle, please. And I repeat, always, not sometimes, always. All right. So this is going to be a over b, and that is going to be equal to, you can see that this negative 3 and this positive 3 will cancel. 2 plus 2, that will give us a 4. In the denominator, 2 squared is a 4, right? Root 3 squared is a 3. So I've got 4 minus 3, which is a 1. You need to conclude, therefore, a is equal to 4, b is equal to 1. If you don't write this, you would have lost a mark from these 5 marks, right? So that is it. We are good, and I wonder why people are failing this question. Is this okay? Are we okay?
Yeah.
Work out the following. The first one, show that square root of 2 is irrational. And this one is also very interesting. You need to make sure that you also show it well. Okay, the first thing, assume, all right? Every time you show that a number is irrational, you use the assumption. Assume square root of 2 is rational. What does this assumption mean, or what is it going to bring out?
It should be expressed in the form of A over B.
All right, meaning that square root of 2 is going to be equal to a over b. Please also state that a and b are members of integers, and b cannot be equal to 0. Now from here, what I want to do is, I don't want to have the root. It is not like those questions which they say, given that this is irrational, show that this is irrational. When they've just given you one, make sure that first you remove the root. So square both sides. So I'm going to have 2 being equal to a squared over b squared. And then cross multiply, you're going to get that a squared is going to be equal to 2b squared. Are we together up to this point?
Okay.
Okay. Now, if a squared is equal to 2b squared, it means that 2 can go into a. That's the meaning. If I say 4 is equal to 2 times a certain number x, it means that these 2 can go into 4. All right? If I say 9 is equal to uh, 9 times x, it means that this 9 can go into 9. If I say a squared is equal to 2b squared, it means that 2 can go into a squared. That's the meaning. All right? So if 2 can go into a squared, it means that a squared is divisible by 2. Okay? So you need to write, this means that a squared is divisible by 2. Now, friends, if 4 squared can be divided by 2, it means that 4 can also be divided by 2. If 16 squared can be divided by 16, it means that 16 is also divisible by 16. If a squared is divisible by 2, this means that also a is divisible by 2. Is this okay? These are the
Yes.
this is the procedure of showing this. Otherwise, if you get it in another way, you might lose marks, dear friends. Okay, now if I say 4 is divisible by 2, this means that the answer is going to be equal to what? 2. And this tells you that 2 times 2 is going to give you 4. Instead of me saying 2, I'm going to say 4 divided by 2 is going to give you a certain integer k. All right? And this integer k, that is the one we are saying is 2. Mean that 2 times k is going to give you what? 4. I hope you can see this. So we are saying that a is divisible by 2. A is divisible by 2. Mean that if a is divisible by 2, it's going to give us a certain integer k, whereby 2 times k is going to give you a. So just this condition we've written down here, a is divisible by 2, it means that a is equal to 2 times a certain number k. That is the meaning. I hope that is okay. If it is not okay, you are free to ask. We are not rushing. The aim is to make sure that someone gets it right when it comes in the exam or in a quiz or in a test. So this means that A is equal to 2k, right? And then you go in this expression. Where there is A, you are going to replace with 2k. So that is going to be 2k. But remember that was A squared, so it will be squared. And that is going to be equal to 2b squared. And then from there you can square the 2 and the k in brackets. You are going to have 4k squared being equal to 2b squared. Divide both sides by 2. You are going to find that b squared is equal to 2k squared. This also means if b squared is equal to 2k squared, this means that what does it mean? Let someone tell me. What does it mean? What does b squared is equal to 2k squared mean?
It means that b squared is divisible by 2 and b is also divisible by 2.
Very good. Means b squared is divisible by 2 and b is also divisible by 2. Now you see, at the end we said A, at the beginning, sorry, we said A and B are integers or co-primes or integers in their simplest form, meaning that there is no number that can go into A and B without leaving a remainder, or A and B cannot be divided by the same number. Now we have just seen that A and B can both be divided by 2. So this violates our assumption. So at the end, we are going to conclude, since A and B are both divisible by 2, this violates our assumption that A and B are co-primes. Therefore, square root of 2 is irrational. That is how we get to show that. Since A and B are both divisible by 2, that violates our assumption that A and B are co-primes. Therefore, root 2 is irrational. Are we okay? Are we good? Are we good? Very good. And part B here, I think should be only one person who got it correct. 3.28178178117 and dots. Now, before we show that this is a rational number, who can tell me which numbers are repeating here?
817.
817, right? So that is what people couldn't identify. How did you know that 817 is repeating?
Because they are recurring, they're not in.
Okay. Now look at the first number. Okay, 2 after the decimal. You can see, you can't see 2 anywhere else, right? It means obviously it can't be part of those which are repeating. Look at the next, you can see 8. Okay, 817. You can also still again see 817. You can still see 817. But people were saying 178, 178. Is that true? 178? No. Look at the last number. It is 7. So definitely it can't be 178 because at the end you don't have 8, right? So mean that this can also be written as 3.2817 with a dash on top, right? That's the meaning. Not 7178, no, or 781, no, it is 817. So this is going to be our equation 1. And then move the decimal point in front of the bar. So how many digits should we move it? Okay, 1. So multiply 1 by 10. So this should be x is equal to 3.12817. So that is going to be 10x is equal to 32.817 as equation 2. And then we are going to multiply equation 2 by what? To move the decimal point to the end of the bar. What are we going to multiply by? So multiply equation 2 by 1000. The reason is we have got 3 decimal point or 3 decimal places. So 10x times 1000 is going to be 10,000x. And then we are going to have 32,817. The decimal point comes here. Just write them again because they are repeating. This is going to be equation 3. Then the next thing, subtract equation 3 minus equation 2. Okay, 10,000 x, which is equal to 32817.817, and then 10x, which is equal to 32.817. Let's subtract 10,000 minus 10. What is the answer? So we can remove a 1 from here, it remain, it becomes a 10 here. We also remove a 1, it will be a 9, right? Even here it will be a 9, and then here we put a 1. So 0 minus 0 is 0, 10 minus 1 is 9, plus that 9 plus that 9. So that is 9990x. That will be equal to these numbers of the decimal cancel. So 7 minus 2, that is going to be a 5. And then I remove a 1 from here, it remains a 7. I put on 1, it becomes 11. 11 minus 3, that is a 9. And then write 7, 2, 3. Meaning that x is going to be 32795 divided by 9990. Are we okay? Are we good? Do you have any question? So if there is any need for reducing, you can look for a number that can go into both. You can start with a 2 if it can't go to 3, if it can't 4, 5, like that. All right, so let's go to part C. Let x be 1.166 and y be equal to 0.33. Express x minus y in the form a over b. Let me first ask, what do you think we should do first for us to be able to answer this question?
I think we should first subtract and then express it in the form a over b.
So how can you subtract something with a bar on top? Like with a bar on top. So the first thing is expressing the form a over b, x and y, and then you subtract. Don't subtract first, okay? Because we have got bars on top. So the first one we have got x, which is equal to 1.166 with a dash here. Now, friends, you can see 6 and 6, and then a dash is at the end. Don't waste time. This is the same as saying x is equal to 1.16. Put a bar here. Like you have got a 6, and then 6 is repeating. It's the same as just putting 6 with a bar on top. Because if I write 6 and then 6 with a bar on top, it means when multiplying, I would be using bigger numbers. Like instead of multiplying by 10, I'll multiply by 100. Instead of 100 by 1,000, it will be making numbers bigger. Okay? So here I'm going to multiply this equation, which is equation 1, by what value? So that the decimal point goes in front of the bar. Are you sure? Very good. Multiply 1 by 10. So that will be 10x is equal to 11.6. And then equation 2 multiplied by what? To move the decimal point behind the bar by 10. Very good. So 10x times 10, that will be 100x. That will be equal to 116.6. You see, I've used very small values, but if I didn't express this in this other form, I would have been multiplying by 100, by 100. That is bad. And then subtract 3 minus 2. Okay, that is going to be 100x, which is 116.6, and then 10x, which is 11.6, 100 minus 10, 90x, 116 minus 11. The numbers after the decimal, I'll not count them since they will cancel. 116 minus 11, 6 minus 1 is 5, 1 minus 1 is 0, and then remain with a 1, right? 105. So mean that x is going to be 105 over 90. From here, if I want, I'll go on and express it in the simplest form. We know that 5 can go into 105 and into 90. So that is 35 over 3, right? Meaning that x is 35 over 3. Also express y as a fraction. I hope it's okay. Do we have a question? Priska, is this clear?
Yeah, which number did you use to divide the phone first?
You are right by asking me, otherwise I would have written something wrong. So the simplest form is not 35 over 3 but 7 over 6. I used a 5. I wrote something else. So x is 7 over 6. And then let's also express y. Y is equal to 0.33 with a dash. This one I can also write it as y is equal to 0.3 with a dash instead of 0.33 with a dash. That's wasting time. Even if they gave you y is equal to, they said express 0.33 like this in the form a over b, you can write this as 0.3 with a dash. That's the same thing. Okay, it's the same thing. You can't be working with this. You can't be working with that. So we can now, what are we going to do first? Do we need to multiply by do we need to take the decimal point in front of the bar? Hello. So we can't take it in front of the bar because it's already in front of the bar. So we need to take it behind the bar. So that would be 10y is equal to 3.3. Okay. So for this one, we just go direct and subtract equation 2 minus equation 1. Since the first equation has got the bar, the decimal in front of the bar, then the second one has got the decimal behind the bar. So this is going to be y is equal to 0.3, and then 10y is equal to 3.3. So subtract 10y minus y is 9y. 0.3 minus 3, that will just be 3. So divide by 9. Mean that y is going to be 1 over 3. And then find x minus y. Therefore, x minus y is going to be x is 7 over 6, y is 1 over 3. Just to make my mathematics simple, since I know we have done so many topics since we started high school. All right, we've done so many topics, meaning that we can easily answer this. So what I want to do is make the denominators the same. So I multiply on top by 2, also down by 2. So this is going to be 7 over 6 minus 2 over 6. So simply subtract what's on top. 7 minus 2 is 5. And then since the denominator is common, that is a 6. So meaning that the answer is 5 over 6. Like that. We are good? Any question here? Very good. Okay, given that square root of 6 is irrational, prove that 5 minus 2 square root of 6 is irrational. First, assume that 5 minus 2 square root of 6 is irrational. What happens when we assume that? What happens?
It will be expressed in the form A over B.
A over B, where A and B? Uh-huh.
Integers.
Very good. A and B are integers and B cannot be equal to 0. Simply take 5 the other side. Or let me take this one since it's negative this side, and then I take this one this side. I saw people making, you've taken the negative 2 square root of 6 the other side and the a over b the other side, but I don't know if people know how signs change. So this is going to be 5 minus a over b, and that is going to be equal to positive 2 square root of 6. Surely you take a over b the other side, the negative 5 becomes negative. I mean, the 5 becomes negative, the a over b is positive. Where on earth? So do the subtraction here, made as a single fraction. This is going to be 5b minus a over b is equal to 2 square root of 6. Divide both sides by 2. So you are going to have square root of 6 being equal to 5b minus a over 2b. So from what you're able to see, 5b minus a is an integer. 2b is also an integer, meaning that the right hand side, where there is that fraction, it is rational. And then the left hand side, we know square root of 6 is irrational. And you know that an irrational number cannot be equal to a rational number. That violates our assumption. Therefore, square root 5 minus 2 square root of 6 is irrational. You can do all this, but if you don't write a nice statement at the end, you lose some marks. And this question is only 2 marks, meaning that you lose one, you just get one. We also want to show that square root of 2 plus square root of 3 is irrational, given that square root of 6 is irrational. Also assume square root of 2 plus square root of 3 is rational. Since it is rational, then that means the square root of 2 plus the square root of 3 can be written in the form a over b, where a and b are integers. B is not equal to 0. Now, for such a case, square both sides. Friends, when you are squaring both sides of the equation, never square these two individually. Please square both sides of the equation, not individual terms. In any topic in mathematics, every time you have got two terms on the same part, you want to square, never square them individually on any topic in mathematics. I hope that is clear, because we are going to do more of this as you get to, into functions. Okay, so what we have is something in the form a plus b squared, and whenever we've got something in this form, just get the first one, you square it, get a power 2, multiply by the first one, also multiply by the second one, and then get the second one, you square it. That is how you expand something in that form. So get square root of 2, square it, that will just give you a 2, and then get the power 2, you multiply by square root of 2, you multiply by square root of 3, that is going to give you 2 square root of 2 square root of 3, and then get the square root of 3, also square it, that will just give you 3, and that is going to be a squared over b squared. Are we okay here? Are we okay? Are we okay?
Yes.
Okay, add like terms, 2 plus a 3, that is a 5, and then plus 2, square root of 2 times square root of 3, that is going to give you square root of 6. Just get those which are inside the root and multiply them, and that will be a squared over b squared. And then take 5 the other side, so that will be 2 square root of 6. So if the 5 goes the other side, it will be minus 5. And that is going to be equal to a squared minus 5 b squared over b squared. Divide both sides by a 2, to be square root of 6 is equal to a squared minus 5 b squared over 2b squared. Again, whenever you get an integer, you square it. The answer is always an integer. So a squared is an integer. 5b squared is an integer. 2b squared is an integer. If you subtract two integers, the answer is an integer. If you divide two integers, that will be rational. So meaning that the right hand side is rational. The left hand side is irrational. A rational number cannot be equal to an irrational number. Therefore, square root of 2 plus square root of 3 is irrational. So that is how we get to show that. So I believe you can answer question 7. You just say x, let x be equal to negative 1.24 with a bar here. Since you can see it is 2, 4, 2, 4 repeating, so I can simply put a 2, 4 there with a bar. So this is the one you're going to work with. Yes, Priska.
So how can you suppose you be given maybe a plus b, then they're asking you to prove that it's irrational? How can you do that?
If they give you A plus B, they say prove that it is irrational. They are going to say assume that maybe B is irrational, or assume that A is irrational. That is what they are going to tell you. Okay? It means that all they've done is, instead of having 1 plus the square root of 2, they say show that it is irrational. They've replaced this with letters. They've said let A be equal to a rational number and B be equal to an irrational number. Then show that A plus B is irrational. So it is the same as this one. So the one that they've said is irrational, you need to make it subject to the formula. Just that. It is the same thing.
Alright.
Okay, so I know question 7 we can answer. Let x be equal to negative 1.24. You've seen how I've written it. I've just said negative 1.24. And then instead of writing 2424, because I know 24 is repeating, so just write the 24 and put a bar to simplify your work. And then multiply the first equation by what? What are we going to multiply by?
by 100.
by 100. So we're going to have 100x being equal to negative 124.24. And then simply subtract these two, okay? Equation 2 minus equation 1. It is going to be 100x is equal to negative 124.24, and then x is equal to negative 1.24. So 100x minus x, that is 99x. Now, this is a minus, remember. So be very careful, dear friends. 100x minus x is given as 99. And then we have got negative 124 minus negative 1. This will give you negative 123. Therefore, x is going to be equal to negative 123 divided by 99. That is going to be the answer. Hope it is not confusing. Otherwise, where there is a negative involved, people get to go in wrong ways.
Question B, is that 11.11 or 1.1?
1.111111. So also question B will say let x be equal to 1.1 with a dash on top. Since one is repeating, right? Very direct. So be question 1. Uh, do you have a question? Anyway. Alright, so we are going to multiply equation 1 by a 10. So we're going to have 10x is equal to 11.1. And then simply subtract equation 2 minus equation 1. So 10x is equal to 10x is equal to 11.1, and then x is equal to 1.1. What are we going to get? This one is very simple, friends. Can someone tell me? 9x is equal to 10, meaning that x is equal to 10 over 9. Very simple. So that was the end of this tutorial. And if you have done this, you can answer any question on rational and irrational numbers.